Okay. One thing was pending also, the hbase and hive integration. Okay, hbase and hive integration. Then I will do nifi installation and two examples on the nifi. Okay, and then airflow. The airflow is orchestration tool, scheduler tool. So I will give the some background of the UG also. So UG is another workflow scheduler tool. Okay. So UG is the part of the Hadoop ecosystem component. You are able to see my screen, right? So UG is the part of the Hadoop ecosystem component. So what are the types of workflow is there in UG? And then I will show the airflow. Okay. So okay. So first we start with the HBase Hive integration. Okay. So for HBase Hive integration is I'm just creating a table in HBase and I'm getting the data from the Hive. So Hive is the interface to read and write data from the HBase table. Okay, so here I have to use the HBase storage handler. Okay, so first I will create a HBase table and I will insert the data, and another table I will create in Hive that will read and write data. That will link with the Hive with HBase, and then the select queries I can read the data from the HBase in Hive. Okay.
What is nifi used for?
Mhm. No, no, this is not NiFi related. This is HBase Hive integration is a separate integration. It's like how to read and write data from the HBase
Yes,
in Hive.
I saw
Mm.
you wrote nifi installation, the second topic.
Yeah, yeah.
So I'm
Second NiFi installation, that will be I will be doing the installation, NiFi installation I will do, and then we will do the pipeline in the NiFi. Okay. So there is a drag and drop component we can do. Okay. First we'll go through what is the NiFi components are there and how we can write. It's a completely drag and drop tool, and there we can write our own processor or we can use the inbuilt processors. Okay, processor is nothing but like a controller, right? Like some action I want to perform, so we use the processor, but processor needs some input, and it will be redirecting the output to the some output component. Okay, so I will show some example of NiFi. Okay, so first I'm just going to show because the last time this HBase Hive integration is left, so that I'm going to cover. So it's nothing but just we have to create a HBase table, and then we have to link with the Hive with HBase. Okay, let me check my Hadoop is not run. So for starting the Hive, we need to run Hadoop first. And can go to the HBase. how to go to hbase. My hbase is installed. Everybody has done the installation of hbase local because this all installation are done. cd bin. So how to start the hbase service? Start hbase service is there. So this will start the hbase service. And now I will hbase shell. So hbase shell will be starting the hbase command line shell. Okay. So list command is showing the list of tables. Okay. So this books table is created and I have to start. So hbase we know, right? We have to create a column family. Okay. So if I want to create a table, so I have to create a column family. So I'm showing you which column family I created. So we can see the linking of the hive with hbase. Always give the name in the single quote. Okay, so if we see this table, books table, yeah, name, analytics, and info. Okay, so name two column families, right? One column family name is analytics and one column family name info. Okay, second, so Richard, your hive is working? Hive and hbase both? Are you there, Richard?
Sorry, I was on mute.
Oh,
Let-
okay.
let
I'm
me-
asking like hive or hbase both are working?
Yes,
Okay.
let me bring it up.
Okay.
I don't know why why it's giving me low disk space. But I know I have a lot of. I allocated 50 gig for this.
Okay, less space is showing.
Yeah, it's showing low disk space. I don't know which one to wipe out. I'm trying to see what's going on. Which one do you think is useless here? Because I don't know. It's a 50 gig allocated. Why home is taking 16? It's taking.
You have to find like which one is more disk occupying, right? The home is taking, right? So
Home is
how much total you gave for this?
it's
14?
50. I think it
50,
took, yeah, 50.
50 is the less, right, for the The 16 is there, and where is the 13, right?
Right.
So two.
Use yeah. I don't know which is.
Okay, I mean, right now this hive is starting. Otherwise,
Can we increase that this space? Is there any way to increase it?
no, it's a very time-consuming process, or it's the
Okay. I
because
tried this
whatever we gave in the first
at the
time.
beginning, yes. I tried yesterday, but I didn't know why.
Yeah, because I seen that this is uh, not that much easy. Because that's the
Yeah.
reason we should always give as much as possible in first time.
I
Okay.
know, I didn't know that. I thought that maybe you can 50. I thought 50 was good. Could have given 100 because I have.
Because when you are going to install nifi or the other one, right? So that will be taking more space. So that's the reason 100. We need 100.
Yes, but if you if you start another one, that means you have to install everything again. It's crazy.
Or I'm formatting my hive. Okay, I share mine one. Okay, okay, my hive will start.
That's why it's running slow. This space. It's crazy.
Okay, I have formatted hive. So I have the command. Actually, whenever the issue is there, so we have to use we have to remove complete metastore db, and then we can reinitialize our derby. So we can reinitialize derby, and then we can start hive. Okay. Now I'm creating now there is no database. Only default will be there. So database. So default is there. Yeah, I create a new database. Okay. So now the testing database is created. So I have to use this database. So show table. Okay. Show tables. Right now there is no table.
Not able.
So this is the example. Like I have to create some hbase. I'm creating a books table, and this has a two-column family: info and analytics. Okay. And this is the data we are writing in the. So info has again three columns, like author, year, two columns. Okay. And analytics has the view. Okay. So I'm writing the data here in the these columns. Okay. And the same thing I will do with the, I will create another table, external table, and I will be giving all those four columns. So four columns which are the part of the column family, like two, how many columns are there? Author, year, uh, author, year are the part of info. Okay. And views are the part of year. And where is the title? Title is a direct field. Okay. So this data, right? I'm here giving the mapping here. So I'm telling about here my survey properties. I'm specifying here the keys, and I'm telling about which is my row key, and info having the author column, info is having year column, and analytics having the views column. So I'm defining this survey properties, and the storage handler, this hbase storage handler is the survey. So this survey is basically mapping the hbase to the hive. Yeah. So I have to create this table in hive. Okay. So I create in the default. We can create in any database we can create. Okay. So here this is the table is created. Okay. Right now, if I see the data, there will be no data.
You have to say default.books.
Because it's taking the database is whatever database I use. Okay, okay. My hbase is already created. Okay, so that is the reason that data is coming. Okay, so I showed you this one. So if I create a new table with a different name, so I have to tell here books one. This is I'm telling table output table books. So this table. Okay, first we have to create here in the hbase. Okay, so I have to create a table. First we have to create an hbase, then the mapping table will be created. Here, focus on. So this is a change. So first command is creating a table, and put command is writing data the book, and like I'm giving some title, and then I'm giving the uh, so here is everything defined as a dynamic. Okay, it's a dynamic schema in the hbase. Okay, so in hbase I'm going to create. So I see here the table books one. Okay, and scan I can do books one. So always give the either column family or you are giving a table name, everything you give in the single row. So we are able to see the data here. This is the hbase table. Okay. Now I'm mapping this hbase table to the hive. So I'm telling here this is my hbase table mapping. So in the hive I'm going to create. Now I do the select. Okay, so that way we can read the data. Okay, from the hive. Okay, so when we want to install the nifi, okay, nifi installation. So what is a nifi? I will tell about. Okay, nifi is ingestion tool. Okay, what is the purpose of the nifi? So the installation things will go to the this nifi Apache org site, and we will find the latest the download section. What's a nifi download? So 1.22 release. So last one I did 1.14. We can do. So we need to download the binaries. So NiFi is just we download first, and then we can start the NiFi. NiFi command, we can start the NiFi. Okay, so we will see the user interface, and that user interface we can do the drag and drop component. Okay, so when we go through NiFi, so basically uh, first we understand like what are the things are there. So another tool similar to NiFi is StreamSet is also there. Okay, but NiFi is the more popular. StreamSet more issue is the with the resources and documentation. and the examples are not available. But nifi is more examples you will find different processors. So there are more integrations, like different clouds you can integrate also. Suppose you want to integrate like AWS S3 bucket, right? You want to read the files and write the data to the SQL database. So you can do the drag and drop component. And for the different clouds, we have the different processors are there. So we need to identify there are the 250s, more than 250 processors are there. We need to find like which processor we want to use. That processor we can use in our application. Okay, we can do.
How
So
do you,
use
how do,
nifi.
how do you make that decision? Which processors to use?
Yeah, so suppose I say I have to read the data from the file. So there is a get file processor are there. So some categories are there. I will come to that. So depending on the category type, you will choose that processor. Suppose I want to read the data from the HTTP layer, right? Some HTTP endpoint. I want to read as a REST service. So I can use HTTP invoker. So different category of the processors are there. So that will be defined here in processors. So so what are the first NiFi key concepts are there? So NiFi having the like a processor group. So processor is a kind of Java module, right? It's a inbuilt processor, or we can write our own custom Java code. So writing a custom Java code, you have to write a code in the Java, and that processor will be like some custom functionality when you want to implement, which is not provided by any processor. So then you can write your custom processor in the Java class processor you can write. Processor group is a combination of some set of processor you want to define as a processor group. Suppose sometimes you say, I have to design I don't want to design something from the scratch. So what you can do, you can create a one processor group, and processor group is a set of processor together, and then you can define the processor group. Okay, suppose I say I have a one pipeline of I'm reading a file, and I'm just reading a file, CSV file. I'm splitting the data, and then I'm done doing some manipulation on the data and writing the data to the some target directory. Okay, so I'm using the get file processor here, and some conversion I'm doing, right? Okay, CSV to JSON file conversion I'm doing. So I can make it a one processor group of these processor, and then I can reuse template. So this processor group entire you can use in the another flow you can use. So that's a reusability kind of thing. Okay, so processor group is providing a more reusability. So we have a flow, right? Flow file is there. So when we are connecting like from different component, right? Okay, I say like one is a input component is there. Okay, I'm reading a file. So some input directory is there, and this input directory I'm reading data by using the get file processor. Okay, and then get file processor is like doing some processing and write the data to the output directory. So here my input is this input directory. So I will be defining some properties. I will define in the get file processor. I will define what is my input and what is my output. So when this NiFi job I will run, right? So it will start reading. So I need to stop manually. Sometimes we can schedule it also, this NiFi job, but we can start and stop manually. And then when we want to read data, so whenever any file is arrived in this input directory, it will move to the output directory. Or any manipulation we are going to do, that will be processed. That will happen. So input directory location will it will find it, how many files are there, it will read. So you will see that file will immediately disappear from the input directory and it will move to the output directory. So get file processor is just reading file, is entire file it's reading and then writing to the output directory. Okay. Another processor is there like publish Kafka. Okay. So whenever you have some messages are coming, okay. So these messages, suppose you are writing to the Kafka topic. So Kafka topic you messages some publish. Okay. So we publishes some messages on Kafka topic. So our so So there is a one publish Kafka processor we need here. So which will read the data from some file. Okay, suppose I'm saying here is a get file processor. Get file processor that is reading the messages from the some input directory. Input directory like files. Input directory has files. Okay. So get file processor is reading, and this one is writing to there we will use the publish Kafka. So publish Kafka processor will be writing data to the Kafka topic. So once the Kafka topic has data, publish Kafka topic. Okay. So whatever data it has, right, it is writing, and then get file then some Spark job. Okay, so this complete flow like we can prepare like once we have, and then separately some Spark job. Spark job will not be here. Spark job is running separately. So whenever this nifi is just reading files and writing to the Kafka topic by using the publish Kafka processor. So publish Kafka processor and get file processor. So two processors are here. Okay, so it is a chain of processor. First is a get file processor. Okay, and publish Kafka processor is writing the data to the Kafka topic, and then separately Spark job will be reading the data from the Kafka topic. Okay, so this is another use case example where we can see this get file processor and publish Kafka processor. Okay, so nifi is also having the registry. Nifi has also having the template. So template is basically I want to create. Here is a template is there. So nifi template is basically when you create one nifi flow. So this nifi flow you can use in another nifi flow, or you can uh, give it to someone as a XML file. So there is a background in the backend is there is a XML is there for nifi template. So that XML file, if you give it someone can import that file in the nifi environment, and then he can use the same flow. Okay, so we don't need to write anything from the scratch. Okay, so that is nifi template, and nifi registry is also there, that is storing your uh, in like a different processor group, right? And generally we store our um, complete pipeline structures. We can like suppose registry purpose is to store some, like in the other cases you see the images we store, right? So similar way nifi also keep it stored permanently your flows. So flows are stored in the nifi registry. Okay, so nifi has the queues flow files, so we have to create a flow files processor. Okay, so first user interface, you see how looks the user interface. Okay, let me open in the windows. So in this nifi user interface, so like this is the category of the, this is the run drag and drop tool. So if you see here on the top, this is the processor. Okay, so this is a processor. So when you drag processor, so it will ask you which processor you want to use. So here is the type of processors are there, like attribute to CSV. Suppose you want to write CSV file, attribute to JSON, like you want to write your attribute to the JSON file. So there is a other like WebSocket you want to connect. Okay, so there are the different processors are there, like Azure and other clouds related processor. So different categories of the like different categories wise the processors are there. Okay, so input port is like you want to set your input port or output port. Okay, so that is for the canvas purpose. Processor group to making it some set of processor to in the processor group. Okay, And funnel is used to transfer the output of a processor to the multiple processor. So this is funnel, template, labeling. So these are the part of the can this canvas. So this entire canvas has the different um, set of properties are there. You can use it. Okay. So when I want to define the processor, so if you see here the get file processor. So get file and put file. So two different processors are there. The get file processor will read the file and it will give to the put file processor, and put file processor will write the file to the output directory. So here in the get file processor, you will define your input directory path. So there is a further properties are there. You see the settings. So every processor has the settings. So when you see the setting here, so there is a like you can set automatically terminate relationship. Like you are saying here, when this process is completed, so you are marking it success. Okay, so you have to select this success. Even you can define failure also, because sometimes if your processor is failed, so in that scenario, what error message or you want to see, so you can define success and failure. Okay, so here these are the settings. So get file, or you can schedule it. If you don't schedule it, then it will be picking up whenever the file is arrived, it will pick all the file. Okay. I think okay. So get file processor properties, like here is a directory is there. So input directory path. So suppose I'm saying my home directory, some input directory path. So whenever the file is arrived in this input directory, those files will be picked up. Okay. So here I can define the size also, like how many maximum file I want to do. So best size I can do. Okay. So these are the additional configuration property, but this property is must, the input directory. Okay. So input directory we have to define. So put file processor is similar to the get file. So same like a get file is need input directory part, and put file is needed the output directory part. So put file, I'm defining the failure and success. If my file is not written, so what will be the failure, and the success will be the default. Okay. So put file also similar way we can define the output directory path. So put file here we can define the directory path, and then it will write the data. Okay. So this is the one get file and put file processor. So how we can categorize the processor? So data ingestion processors are there. These processors are reading data from the input source. So get file is a one, get HTTP is one, like I want to read from the some HTTP endpoint, I want to read the data. So I will use get HTTP. So I need a get HTTP URL, right? From which URL I'm going to read the data. FTP, from the FTP, get Kafka. Okay, suppose I want to read the data from the Kafka. Okay, and routing one processors are there, which is routing the, like you want to um, set the attributes in a file. Okay, route on content, control rate, route text. So different types of processor. Database access processor, when I want to read the data, especially from the SQL databases. So we have SQL queries, execute SQL, put database record. I want to write the data in the database, so put database record. List database table, I want to check how many tables are there in the database. So list database table. So then, so whatever processor you are using, so what output is coming from the that processor, that can become input to the another processor. So you need to check like, okay, what will be the sequence of the processor? Okay, like which processor I need to call first in my pipeline, and which will be the next processor. So you can create a complex flow depending on the use case, right? Whatever the process we need to add. Okay. Okay. Okay, I will copy it to in my software. Okay, this is having bin folder. So we have to start the nifi from here. Nifi dot. Okay, so go to the bin directory. Tell when I want to start. I have to check the UI. Okay, we can check the port also. So sometimes if the port is conflicting, we can change the port. Go to the conf folder. Nifi property is there. The admin port 8443 and HTTP port. Default port is the 88. We can check with the log, right? What is the error? So there is a log folder. You want to check if I use the log. It's not currently running. Okay, invalid port configuration Wi-Fi property. Into -9. I kill the No containers. Yeah, let's say that. So data transformation processor, sending data process. So they are the different process categories are there. Okay, so like suppose I want to send email, so we can use put email. FTP, I want to write the data, or I want to write the data into the file, to put file. So it's similar to the ingestion processor. So we have sending data processor also. Right, those are sending the data to the target component. Some HTTP processors are there, AWS processors are there. So AWS processors are related to AWS services, right? I want to read the data from the S3 file, write the file. So fetch processor, get SQSQ. So different types of processors are there. Okay. So processor relationship by success message, right? One processor is success, then it will call the another processor as next processor. Okay, so basically the relationship between the process by using the success and failure. So we can define the flow, right? After the failure of the processor, so it will come exit from the flow. Otherwise, it will keep calling the another next processor. So it will call the processor one after one. So here we can define the either the failure or success. And there is a queue is there in between the processors, right? You can define a queue. So whenever messages are transferring from one processor to another processor, so it will be showing you the queue. So how many messages are there in the queue? So you can see here the queue, and we can define the target endpoint, right? Either failure or success. So depending on that, we can uh, define the our destination. Okay. Okay. So flow file is the file in this you define it's a basic processing entity. Okay, it contains the data about the attributes, right? Whatever the process we are using, processor to process data. So all those information about the process, all this information will be stored in the flow file. Okay, so that's flow file, queue. These are the uh, separate components are there. Okay, so like, and I say queue. When you click on the queue, right click on the queue, so we can see the how many messages are there in the list queue. So list queue means will be showing the how many messages are there queue. So you can see all the messages. So you want to go for this queue source or destination, so you can click on this and then you can go to. If you want to create any template, so template option is there. We can do the template. We can create template. Yeah. So processor group is like we are defining the processors in the processor group. So we can combine the processors and we can make it one a single group, and then we can give it the name to the processor group. So we can create and we can define how many processors are there in the processor group. So we can see list of the processor groups also, and within a processor group we can see what are the processors are included in that processor group. Okay. Label, configuration, template. So these are the all the properties are there, right? Property file, we see the property, and these are default values are given, but we can change these values. These are the configurable properties. So we can change port and those things we can change. So here, these are the different types of properties like core properties and state properties. So this is like cluster level properties also there. So nifi can have the set of nodes, right? If the NiFi is running on the multiple nodes, so we can use the cluster level properties. So those properties also we can set, and we can provide using the zookeeper, right? As the high availability purpose, we can use, can configure. So flow file properties or different types of properties configuration we can do. This properties in the nifi.property file. So nifi property file in the conf directory. So there we can change the properties which are related to nifi. If we can change. So administration things we can do, like there are different nifi flows are there, process groups. So admin activities are basically uh, like some activities like HTTPS. Okay, we want to access our nifi URL on the HTTPS. We need to configure for that HTTPS. Okay, other administration activities. Okay, so it's moreover related to admin related to manage all the different nifi flows. Okay, so labeling is like suppose I'm working in the some flow and you are working on some flow, so I can give the label, and inside my label I can go different my nifi flows. So here someone flows will not be mixed with the other one flow. So we have the label. So we can go inside labeling we can do on the nifi flows. Okay. Mhm. Okay, we change the nifi. Windows. port configuration, port nifi wave HTTPS port and nifi wave HTTP. Okay. That Has anyone downloaded this nifi? Dinesh, have you downloaded?
No.
Hello. Okay. Because it's nothing is related to any other thing. If you have Ubuntu setup,
Yeah, but I'm away from my laptop today.
it should not be problem if we are taking it the default port. It should automatically start. This at all is not starting. So the default of the port. Same property we have to make it. Now looks fine. Yeah. Okay. Actually, we have to remove this HTTPS property. Okay. So this HTTP property, you will remove it, and then it will start. This property we have to remove because the one blog is saying, just the Stack Overflow is saying, right? If you are having HTTPS configured, so you have HTTPS is a higher priority. So if your NiFi remote input secure is enabled, so you will get a higher priority on that. Okay, so that is the reason you will not be able to start. Okay, so you should make it, you should remove it. Then you should, when you want to do some admin activity, then we can do the secure property too. Then we can open the 8443 port is there. There we can. Okay. So here in the NiFi, if you see, so here is when we see the canvas, this is the canvas. Okay. So I will be using this the processor. So I will drag the processor. So I will use here get file processor. Add this processor get file processor. Okay. And I will add put file processor. Okay. So this get file processor, we will set the right click it, configure, go to configure, and here have tooling properties here, input directory. So here I will give the input directory path. So I will go to one directory. So I will copy some file. So in this one, I copied this file. Okay. So when I will start the flow, then only it will start. Okay. So I will take the property of this. What is the directory path? So this path I'm giving my input directory. So I will be defining my input directory. Okay. And file filter also you can do. Suppose you have a lot of files, but you want to do only for text file. So you can do, you can define the filter property. Best size is there, or these properties are there. Relationship. So here is automatically terminate or success. Like I want to terminate. Okay. Settings. Okay. So here I will apply it. And if you see this triangle mark is showing is like your property are not configured. And what are the properties are not configured? So you will see the listing of those properties. So here is not mark is not coming, but it is showing a stop sign. But I can start it, but there is no, it will read the file and it will keep it in the buffer, but it will not be able to give to any other next to component. So I have to make it link connection. So connection I have to set it. So I will be setting the connection. So just I set the connection. So I got here the queue. Okay. So it is just connection here. In the put file, I need to configure property, configure. So here also you have a relationship, right? Finally, you want to terminate in the case of success or failure, you have to select. and here is the output path property. So I want to say like I have a file in my one directory, and I want to create a one. I want to create one output directory. Okay. When I say output nifi, this directory path will be my output directory. Okay. So I can copy the file from the Hadoop file system also. Okay. So from Hadoop one directory to another directory, we can. So I'm setting my output nifi directory is my output part directory. Okay. So this all the properties I set it. Okay. So some more scheduling things if you want to do, we can do. It's all control in our hand, right? We can define. Okay. So right now it will be auto trigger, right? Basically, it will keep checking. So whenever files are coming, it will be reading file from one directory to writing the file to the another directory. So here now I will be start the one, but you will see here my put file processor is still not reading. So okay, from here the files are gone. Okay, yeah, it came into the queue. So because my put file processor is not started yet. So if my put file processor is not started, so this files will remain in the queue because the get file has done its on task because it is keep running. If I'm just putting another one more file in the input file directory, okay, so I'm just copying another file, copying it and putting it into the here. So you will see this will be automatically gone. So now you will see 5 will be here. So in the queue will become 5. Yeah. So now your data size is increasing, right? So it has total data bytes it has read, and it is saying 5 is the output of this one. So queue it's there. Now I will start the put file processor. I start it. So you will see all the 5 files will go to the output directory. You go to the so you are able to see. So it will be very, very fast, right? When I write file there and it will be. So now if I write the file in the input, okay, it's gone. And now if I check in the output nifi, file is here. Okay. So this is basically the get file and put file processor. Okay. Okay. So if I want to get the data from the file and write to the Kafka topic, okay. So I have to use the get file, and but get file will be writing data to the publish Kafka processor. So I create another processor. Publish Kafka 2.6, this one. Okay. So here I need to configure the property. So I have to specify the topic. So I have to tell the which topic I want to write the message. Okay. So here the properties are there. So default is taking it the localhost 9092. Okay. So I have to specify the topic, which topic I want to do. So I have to start my Kafka. So here you can find the commands of the Kafka. So I will start my zookeeper. To start server.property, server, Kafka server. Says I have to verify the topic. So how to verify topic? So there is a topic command topic we can create, or we can see the list of the topic. We can see there is a list command. Kafka topic. I think we can do simple minus minus minus. Here is bin Kafka topic.sh. Okay. Bootstrap server. Bootstrap server. So server or zookeeper both should be run fine. Okay, so this topic is created. So I will give this topic to my file. Okay, what property we need to Okay, success failure, upstream connection is in the relationship failure, success, and delivery guarantee is invalid because you know that transaction. Either change the relationship we have set it. This is mandatory. Another one property is this one. Okay, so I will be sending the message. So here my files data will be coming on the carpet of it. I will stop this on. I have to verify. Okay, so one is coming in the queue because this message is going in the queue, but here I stopped it, so it will not go here. Yeah. So it is going to publish. Okay, so one is received by the Kafka topic. So now we verify by using the consumer here. So we don't need to start the console producer. We can directly check the same topic by console consumer. And same way we can take the data in the Spark, like some Spark read stream function, we can read data from the Kafka topic. So this is coming. So if we verify the file, what file I put it. Just I put this data. This file I'm just going to put nifi. The data is coming. Okay. So here this is the published Kafka. Okay. So when we want to read the data from this Kafka topic, we can use the Spark consumer. So nifi is basically using the get file or put file processor, or we can use the. So how to create a template in the nifi? And you
Any predefined template you use? Any predefined template you can modify?
can we define template?
A predefined.
Predefined template. Yeah, you can take it any template from the Google and then you can import, like entire flow will come, right? Okay.
Okay.
So
That's easy.
there are so many template, right? So you don't need to scratch anything from the design from the scratch. You can take it. nifi template example. Okay, so just you need XML file and just import that file, the nifi. There's so many templates, like different process you can understand, like how to read CSV, JSON file data, how to splitting the data. There's a different types. See, this is so get CSV data, validate it, and route to the Kafka XML. Okay, like one with hbase, nifi web service, handle nifi. Okay, MongoDB, right? Get and file. Okay, so MongoDB. Okay, so this template I will download it.
Can we write it to a JDBC?
Yeah, the JDBC means like we have this database record, right? So database record related processors are there. Mm, yeah, so that will be doing the JDBC connection itself, right?
No. If let's say if there's an event happening on the database, can we write quickly something or it's not?
You want to say like you want to connect database?
Yeah, connect database and any changes happening like a stream happening in the database. Can we quickly write
So
into a
you
file?
have to see again, you have to start the processor, right? So see, processor work is to, okay, you mean to say anything is in the happening in the database, like some record, so automatically record will be get. Yeah. So you don't need to do, because that's the automation, right? That is the automation of the nifi. So this nifi is keep searching things, right? Okay, if it is connected with database, so it will be checking if any record. So we have to set the property, right? Whether I want to give for insert, update. So whenever any insert is done, this nifi is like keep checking in the database, and then it will find. Okay, because it will easily find if anything happened in the database, so it will pull the record. So database record, database one.
So it doesn't do any transformation. It just copies the file. That's it, right?
No,
We cannot write
this can transformation also can do. Processor means you can write. These are the inbuilt one. Okay, but suppose you want to write your custom business logic you want to perform, then you will write a processor. Okay, in that scenario you will go for your custom processor, because your business logic they cannot implement, right? They are like, suppose you say, okay, I want to just simply uh, encryption decryption logic. So some but still they are writing on processor also. But where you have to just simple read the JSON file, or there is a straightforward processor are there. If I show you some processor, like for there are many category of the processors. The attribute to CSV, write the data in the CSV. Extract is there. See, extract abro metadata, extract email attachment, extract email header, extract text file data you want to read. So there are different, just you have to provide input to this processor. You select this processor, and once this processor comes,
So what kind of logic, if I want to write a processor, it can be Java, it can be anything, or
Java logic you have to write. Okay, but this is here is no logic required, right? Here is a logic in the property you will define. Logic
no.
means property.
If I want to
Like
write
if
any,
suppose if I go to see,
if I write a business logic, a custom business
yeah,
logic, which
extra something business logic also we can write. Okay, but here is not a language. In this one, this is the inbuilt one, right? Inbuilt processor. Okay, so inbuilt processor you are not able to write logic, but you write separate processor for your custom processor. Okay, here you have lot of properties. See, whatever the functionality it is giving, it is like some extent you can provide those functionality, like enable multi-line mode. Okay, and parsing of the pattern, some pattern you want to define. So as maximum as possible they are providing the custom changes, but these are all changes through the configuration, not any programming. Okay, but when you want to do that, you have to write your own custom processor in that scenario. In that scenario, you have to write a custom process. Like create a connection to the different SQL databases, query a database. Query record processor. Like select query, like you want to read the data. So query record first. Suppose you want to read the data from the MySQL DB. So connection, JDBC connection, everything you have to give in that process. The get CSV file, add schema name attribute, query record, and then update attribute, update record. To SQL. This is a database related. See database select, yes, select JDBC query SQL, execute SQL record. SQL record. So we can see the property, right? What is the property here? Okay. So where is the connection? Where is the connection? The query. This is the one execute SQL. But before that, you have a JDBC connection, right? So we have to, first of all, we have to get the data, right? From the, this is reading from the file. This is not database. Execute SQL one is the database. Okay, select query we are giving here. Okay, DB connection pool. Some separate connection pool we have to create, and that connection pool to control. Yeah. Okay, I will find the example. Okay. Okay, 10-minute break. I will start the airflow. Okay. Yeah, are you able to hear me? Hello?
Yes, we can hear you.
Okay. Okay. So first is the UG, okay, because UG is a part of Hadoop ecosystem component as a scheduler tool. Okay. UG is a scheduler tool inbuilt uh, to Hadoop ecosystem. Okay. So earlier we used to use UG. Okay, UG is a workflow scheduler tool, and UG has three types of workflows. One is a simple workflow. Okay, simple workflow we can execute, and the second one is coordinator, coordinator, and the third one is a bundle. Okay, so this simple workflow is we have set of actions, right? Different actions we can run. It could be a hive action, scoop action, Java action, or we can say Spark action, shell script action, okay, bash, call the bash action, okay. So different actions are there. So workflow is nothing but a XML file. There is a workflow.xml file. In this workflow.xml file, we are defining one root tag workflow, and inside that there are the different actions are there. So if action name is some unique name we are defining for our action, like hive action, and we have to set some input output property for this hive action. So there is a command will be there. So one tag will be command. So what command we want to run for the hive action, right? I want to insert data, I want to select query, I want to update, delete, any SQL queries I can do. Or I can provide an input file, like suppose my uh, like hive script. So I can command, I can give some hive script also. Suppose my hive script file is a abc.hql. So this abc hql is my hive query language one. abc hql is a file. There my set of commands could be there. Okay, and I want to this abc hql is taking some input and output, right? What it has to do. So we can define those input output parameters. Okay, so then we can close the action tab. So this is the one action, but suppose there are multiple actions could be there, right? I say first I want to call the hive action, and then I want to trigger scoop action. So I say I want to do scoop action first. So I will say action name is a scoop action. Okay. So I want to start with the scoop action first. I want to ingest data from some MySQL database. So I will be providing the scoop import command. Okay. So I can give it that command through the shell script, or I can give the command through directly here, the scoop import command, and that action will be done. Then next action will be triggered as a hive action. Suppose I want to run the action parallelly when there is no dependency. Suppose if I say hive action can run when the scoop action is done. Suppose I want to read some file from Hadoop file system and then write to the hive table. So for that, I need to write the data to the Hadoop file system by using the scoop command, right? So scoop import command will be there, scoop import, and this command will be like minus minus connect, username, password, so those parameters, and I will be providing a target directory. So target directory, I will be giving a directory location where I have some output file. I want to generate output file, and this hive is reading that file and writing data to. Suppose I'm saying I'm just have written a JSON survey. So I'm okay. So I'm just writing the output file here in the SDFS direct target directory location, and the another action is a hive action that will perform. So here we cannot run action parallelly. But suppose there is a scenario, I want to say like two different hive actions can run parallelly. I say one is reading one is doing the one command, right? One HQL, and another one is doing another HQL. So I can start the fork here. So fork is, I can define the fork and say how many action I can give the action name. Okay, I pass it here. Action is a reference of the action I can give. Okay, I gave hive 1. Okay, so this is a hive 1 action, and this is another action is a hive 2. So 2 fork I want to start. I say hive 2. Okay, and then I will close the fork. I will close the fork. So down there is a this is a one hive, and then another hive action will be hive 2. Okay, so this is running some ABC and ABC1. Okay, so this way the fork can be done, but fork is for running parallelly. Like two action you want to do parallelly, then we do the fork. Okay, so this is the workflow. There you define the set of actions and define the sequence of your action. Okay, how you want to perform your action. It could be any action. It could be a Spark action. It could be a Java action. It could be a shell script action. So if you're defining the shell script type action, so you have to give the shell script command, because shell script command you have to give. Suppose this action is a shell one. Okay, so shell script type actions you have to give the abc.sh. Some shell script file, some location you can give, and that location the shell script file will be. It shell script is taking some input parameter, some command line parameter is taking. So you will be providing through the input and output. You want to write something, so you can say output. Okay, so this way we will define a set of actions, and this is defined in the workflow. So when you want to run a UG, so UG is running on the local host 11,000 port. Okay, so this is a UI of, so UG need to install, and it is very complex installation, UG installation. Generally in the Cloudera we can get UG, there we can do practice like Cloudera CDH, that is ready made to write. The UG is already pre-installed, but when we are trying to install in Ubuntu, so we can follow some installation. Okay, so UG installation is there, but it is okay. Here it's giving you complete step, but this is complete one Java application you have to create, and this one is basically to complete UI things. One Maven application you have to run, Java Maven application. Okay, so this application you need to download the star file, and there right you have to uh, bin directory, and then you have to run application compile, and there is it is using the okay. So so this installation once done, then you are able to start the you will get the interface like this. So it will be running on the local host 11,000. So whenever your UG job is invoked, so how to invoke the UG job? So one more thing is needed for the UG job to run. One is a workflow, and another one is a job.property. So job.property, you have to define what is your name node host. Okay, name node host. Okay, job tracker, your resource manager host, and workflow.xml path. So basically your workflow.xml will be invoked from the job.property. So when you run the UG job run command, UG job run, okay, and then you specify minus minus properties, then you can give the job.property, job.property. So job.properties name you provide here, and when you run UG job run command, so one workflow ID will be created. So this workflow ID will be starting with the W letter, and some number is given. And this workflow ID, you can see the status command line. Okay, so UG job status is their command, UG job status, and then you can provide your workflow ID. This workflow ID you can provide. So it will tell you the status of your job. So this is the command line, but you can see the same job on the here job ID. You can see job name, when it is started, last month end date. So you can see complete status of the job and the command UI also. Okay, so this is the workflow type. Another one is a coordinator. Coordinator is another one extra file will come, coordinator.xml. So coordinator.xml file have the frequency of a job. suppose you want to define your job, you want to say your job should be running on a specific time every day. Okay, so you want to define the schedule frequency of your scheduling, job scheduling. So that you can define the frequency of the job scheduling, you can define in the coordinator.xml. The coordinator.xml file has your like when you want to start job, when you want to end job, and what is the frequency, like a daily basis, and what is specific time, right? So all those parameters we define coordinator. So when it will be using the same workflow.xml, but coordinator.xml has this extra property. And bundle is like you will be making it a combination of workflow and coordinator both. So you can use the bundle. So multiple workflows with coordinator job will be there in the bundle. Okay. So mostly we do either workflow or coordinator, because coordinator is solving the purpose of scheduling of the job. Okay. So how job.property look like? Okay, job.property and the job and stuff. So if we see action node, so you can see these are the types of action node. Like MapReduce action also you can do, Java action you can do. So these are the properties are there. Like when you see the workflow, so action name, you are giving a name of the action, and that type is you are defining MapReduce type. So MapReduce, you know, right? Job tracker, name node. Okay. So what is a mapper class, user class, input directory, output directory? So all these information you are defining in the MapReduce job. If you are defining any pipe operator, okay, so you can define Java action. So you can define the Java type, Java action. Okay, so you can define. So this is all the different types of actions. Okay, if you see like this workflow is there. So fork, I told you multiple jobs can run parallelly, and then it will combine the output, and then it will be calling the next one. So it will be calling a different action. Okay. So control flow and action node. Okay. So action node, like you can define which type of actions are there. Okay. So control flow node is like where you want to decide, right, which path you want to follow. Okay. So those are the control flow nodes, and action nodes are the nodes which are defining the action. Okay. Okay. Coordinator is having the coordinator.xml file. Story of file. Okay. Yeah. This is the property file. The property file, you are defining the job tracker, script name. Okay, so you can give some script name path, some extra parameter, like which parameters you want to use in your workflow. Then those parameters you can set it from the job.property. So you will change here, it will be reflected to your. So here you can use the dollar symbol, you can use those parameters like dollar job tracker. So it will be taken from the job.property. So suppose I'm defining the hive action. So I'm bound to create an external table in the hive. So my workflow is starting with the start to, and there start to, I want to say action name. This is the first action. This is the second action. Create ORC table, create external table, insert into hive table. I want to insert the data. Okay. And then if it is my error is coming, I'm calling the separately kill job. And kill job is just I'm sending a message, or I can send email alert. So when I kill job means I want to say the job is failed, and I want to send the failure message as an email. Okay. Uh, okay. If I want to insert data into hive table, I have a job tracker, name node, script name, parameter, database parameter name. So these parameters I can take it from the job.property. Okay. So how to run? Okay. How to run the workflow? So uji job command. So this is the step, right? How to create a workflow.xml. This is the workflow.xml. And run command is a uji job. Okay. This is the run command minus run. This one. So you are specifying this workflow path you can give directly in the command, or you can give in the job.property. If you give it in the job.property, so you can give the here job.property you can specify here. You don't need to give the workflow.xml because the workflow.xml is the job.property. So you can give the here job.property name. Okay, so here job.property name you can specify, so that will take from the job.property. And then we can see on the 11,000 port. Okay, if you have installed yourself, right, your own UG, you can configure on the 8080, but by default port is 11,000. Okay, fork and join control node. So we can define either fork or join. So fork is basically multiple actions we can define in fork node. Okay, so there we can run parallelly the multiple actions. Okay, so that is the fork. Decision node like a switch case kind of thing. Generally in programming we use the switch case. So we have the case statement is there, right? Like conditional statement. So this complete workflow is can be decision based, right? Like, okay, I want to, based on the condition, I want to say if file exists, okay, then I want to perform this particular action, or otherwise I want to go for that action. Okay, so that way we can do. And coordinator, if we go to coordinator, so coordinator is having this coordinator.xml, this coordinator.xml. So coordinator.xml, I'm telling first in, first out queue. What is the frequency? This is a 5 minute. This is a 5 minute interval. 5 minute interval, the job will be keep running. Suppose it is reading data from some folder, and we are not sure like when the data will be arrived in the folder. So it will be keep running this job every 5 minutes. Whenever the data will be there, it will process the data. So we can schedule it through the coordinator.xml file. We can define this properties, right? We can define the configuration, right? When the job should start and till which date and time I want to end the job. So coordinator also you can fix the start and end point, right? Okay, and you can define the which workflow you want to apply for this coordinator. Okay. So only this is the extra property, and these are the job status are there. There are the different status are there, like your job is running, scaled, okay, suspended, okay, pause, right? So they are the different job status are there. Okay. Okay, so this one is about 2G. Okay, so now we come to airflow. Okay, so airflow is we can say there is no dependency on the Hadoop. Okay, because in the UG you need to install Hadoop, and then only you can use UG. So UG has a dependency of SDFS, right? Hadoop. Okay, but when I go to airflow, airflow is an open source tool, and it is developed by initially Airbnb. Okay, so airflow is a Python based DAG scheduler tool. Python based DAG scheduler. So what is a DAG here? DAG is same like it's it's a set of actions, state it maintains. So when it is having a workflow, right? So it's like different operators are there. Okay, I will tell about what is the operator. So they have given the action is the operator here. Okay, so what we call there in UG operators actions, here are the operators. So we have different operators are there: bash operator, hive operator, scoop operator, we have sensor operator. Okay, sensor operator is like to check whether the file is arrived or not, sensor operator. And we have a spark operator. Okay, and all cloud related operators also there, like is specific to the cloud. Suppose I want to go for AWS, so AWS operators are there. Okay, so if I go for Azure, so Azure related different services operators are there. If I say Azure is having data factory, okay, data breaks, all these data factory, data breaks. So those are the different categories of operators are there. In the AWS, we have a S3 operators, right? S3 service operator, okay, glue. So all maximum number of operators they provide. GCP also having a BigQuery operators. Like if I want to read the data from the BigQuery, so BigQuery operator, okay, big table operator. Okay. Some name is there, a specific name. So they are the different BigQuery, but what you want to do, right? Read or write table, right? So generally, the BigQuery is a table, right? It's a data warehouse tool in GCP. Like AWS, you are using Redshift, right? So Redshift operator there. Okay. So depending in the use case, right, there are the different operators are there. So you will be using specific. But general operator, when I say most of the time, if you are not using a cloud, so we will be using these operators, either shell script operator, hive operator, scoop operator, sensor operator, or Spark operator. Okay. So some other operators also, their dummy operator is there, like for some dummy task. Okay, Python operator, that is very most important one. So suppose you want to run any Python function, you have some Python utility function you want to run, you will use the Python operator. Okay. So basically, Airflow has the Airflow server and Airflow scheduler. Two things are there. Airflow server, web server. So Airflow is nothing but a one web application, okay, which is running on the some port, okay, 8080 port is running, and this web server, when you install Airflow and your Airflow web server service you start, and you have to start scheduler also parallelly. Okay, both the services will be running Airflow scheduler. Okay, then you can see your UI of the Airflow. So there is a separate UI is there. Okay, so localhost. Okay, and then you say 8080 Airflow. So Airflow UI will be giving you the DAG. So whatever DAG, so basically in Airflow there is a DAG folder is there. So whatever DAG we create, DAG is nothing but a Python file. A Python file we create and put in this DAG folder. Create and put into this DAG folder. And once we keep it in this DAG folder and my Airflow server or UI scheduler is running, so this DAG is exploded and it will execute the DAG. Okay. So I will show you like one DAG example. Suppose I have one shell script DAG I'm going to execute. So I have written this shell DAG file. So I am using the bash operator. So I have to tell which operator I want to use. So I will write one DAG file. Okay, I will show this. Before that, what are the other components are there? So Airflow is having the server, Airflow is having the scheduler, and Airflow is using its own metadata database. Metadata database. So it's SQL Alchemy. Alchemy is a small SQL database that is used by the Airflow as a metadata database. So this database will be initialized at the time of installation, okay? And all the metadata about the job will be stored in this SQL Alchemy, okay? So we'll see that at the time of installation process. So this SQL Alchemy we need to configure, and metadata database. So what are the key components? So one executor is also there. Executor is actual who is performing the task. There are the different types of executors are there. One is auxiliary is there. Okay, distributed is there. So Airflow architecture. So when we look at the Airflow architecture, so we have a web server, we have the scheduler, and scheduler is basically coordinating to the executor, and we have database, metadata database. So it could be a Postgres or SQL Alchemy. So anything it could be. So these are the main components. So web server, scheduler, executor. So executor is a sequential executor, local executor, Slurry executor, or Kubernetes executor. So sequential and local, these are the for local means like only single machine one. But Slurry is a distributed one, like when we have a cluster environment, like we go for the Slurry. On Kubernetes, when we are using containers, so we go for the Kubernetes executor. So most of the cases, like if I'm running the local one we are using, or sequential we are using when we are running in my local machine. But when we are running in a distributed environment, the cluster, I use a Slurry. Okay. So web server, when we are web server, so this is the Airflow UI, right? You will see once the Airflow is installed, we can see the DAG. So this is a tree, like there are two different mode we can see the DAG. Okay. So this is a visualization of DAG. So first we need to find our DAG. Okay. Like there the list of DAGs will be coming in the this Airflow Web UI. Okay. So Airflow Web UI, we can see the DAG, and then we can select our DAG and we can monitor the DAG. Okay. And we can monitor the job through the logs in the that particular DAG. So Apache Airflow executors, so these are the different category of the executors, will run only one task at a time. Run task by spanning processes controlled fashion in the mode. So these two are mostly used for the local system, but Slurry is for the distributed, and Kubernetes one is for uh, container. And Apache Airflow metadata database, so SQL Alchemy or whatever is Postgres. So whatever way we are getting the installation step, so that one will be installed. Okay. So first we need to see the installation step. How to install Airflow on the Ubuntu. So Python should be installed before, because it is using the Python. Basically, it's a Python.
Can you send us that link, that
With link.
installation link?
Yeah. There's installation. I will give in the notes also. I'm giving here also.
Okay, that sounds good.
So, this repository update command. This is nothing related to Airflow, but Airflow needs this command to be done before.
So on Windows, we normally work with Airflow using Docker because of the dependency that comes with it, so that it doesn't affect
Through Docker,
the
we can
other.
use. Yeah. Airflow we can do through Docker also. I have.
But if we install it on Ubuntu directly, it won't affect our.
Yeah, it is like a container and it will be very quick, right? Okay, because
Okay,
if we using Docker file and just we run the, so it will make it our Docker, like a through Docker container. So I think here is the step directly from one Udemy course material I downloaded. This is a Docker file. Container one will be more like reliable, right? Because container will be sometimes up, sometimes down, right? So yeah, container is deleted, right? So like your data and everything will not be, yeah, saved, right? So installation one you can do before doing the Docker, because if you want to do Docker, then everything you should keep it on Docker, right? Like Cassandra, Kafka, everything you running in the containers, then you do the integration. Okay. For practice purpose also, this Docker container one is good. So it will be easy to install, and then we can do that. Which is Docker file. So this everything, whatever steps they have given in this Docker file, just we have to run this Docker file. So it will do all this setup.
Excuse me. When you're talking about Docker, are you referring to Ubuntu as well or outside Ubuntu?
No, Ubuntu. Docker we should have first in Ubuntu. We have to install the Docker, right?
Okay,
Docker.
first, Ubuntu. Oh.
Yeah. Then we can use this Docker file. So Docker build command we can run, and then we can do. These files we should have in our, and Docker should be installed. So without installed Docker, so it will be going to this path. Okay. So here is the Docker file. We are defining the instruction. These are the instructions there. Like env is the one instruction, run command is the one instruction. So whatever command we are running manually, right? apt get update, all this and all commands. So it is just doing automation through the Docker. That's the only thing. Okay. Everything I'm doing manually, but the Docker container is a lightweight. That's the thing, right? It's not taking the huge memory. So it is like container up and down, right? Whenever I don't want to use, I can make it container down, right? So I will not be using the resources. So that's an advantage using the container. And then I'm exposing the port 8080, creating a DAG directory, right? For this. Yeah. So we can this file, Docker file entry find.sh.
Excuse me. What happens if you have already installed Kafka and all this? Do you have to reinstall them in the Docker?
See, that Kafka is which you installed it. Okay. When you are doing everything in the containers, then that container one you can use it Kafka. Okay. So like you have Kafka, Cassandra, Spark,
Exactly.
everything on the container. So
Yes.
you should not start that service, because both will be using the same port, right?
Exactly.
Okay. Because correct.
Okay.
So you just don't start that Kafka service. You just use the container one. So when you're using container one, so container one will be used, right? So at a time, only one, right? You can use it, either container or, but container one is you will be using when everything is on the container. Like one container for Spark, one container you have done for the Cassandra, one container for uh, nifi. So everything you want to keep it. So then you go for container one. Yeah,
Okay.
right. Mm.
When you talk about container now, I'm probably confused. How do you install the container to install the?
So you either use the Docker file or you use the compose by ML, Docker compose by ML. So there is a Docker compose by ML. There is a set of containers are there. So if you do Docker file at only one container, you can do. But suppose you have to do multiple containers, like you want to do like Kafka, Airflow, Spark, everything. So you have to do like I'll show you one container like this one.
That's probably why I'm having is bogging down my
Like
system.
Airflow, Kafka, Spark, Docker. Okay, so this has the container. Okay, Docker. So one composed by ML file. This one, Docker composed by ML. So this Docker composed by ML, you see, like one is the Postgres, which is needed for the Airflow. Okay, so you define the Postgres database. Airflow, you define the Airflow container. So
Yeah.
there airflow, you are defining the container name, what will be the name of the container. Okay. And you are saying depend on the Postgres, because Postgres is a metadata database, right, for the airflow, right? So you are saying airflow depend on the Postgres database. And what type of executor you want to keep it? You are saying local. Volume means like suppose you want to share some data, right, files you want to copy in your local directory and going to the you are accessing in the container. So suppose you created one DAG folder in your Ubuntu directory, any Ubuntu home directory, some DAG folder you created, and this DAG folder, whatever you copy something, it will be going to the, it will be mapped to. It is like a mapping. You
Okay.
can say this side is the source and this is the target, and this target is a path of your container. This target path is a container. So this is a airflow container. Inside it, definitely this path will be there because this is a airflow container, right? Because airflow container will have the user local airflow is installed, and installed the airflow directory has the dex folder. So whatever dex file you copy in your local machine, right, Ubuntu machine, it will go here. Okay. So generally you need a dex file here, right? Suppose I have one dex file. Okay, in my application, one dex file is there. This is my dex file. This dex file, this Python dex file, I will copy in my home directory, some dex folder. That will map to the this one. Okay. Otherwise, you cannot copy paste like a manually, right? It's not. You can just like a virtual, right? It's kind of virtual, right? So this container directory you cannot go manually. Manually you can't go. You go by setting the volume. You set by volume. Okay. And port is, there is the internal and external port is there, right? So which port you want to expose your airflow. So you have told here 8080. You expose. That is a default port. Zookeeper. So Zookeeper you define for Kafka, because Zookeeper and Kafka both are related, right? So you this using the Zookeeper. So this is the image. So these are the somebody's image. This is not official image. So if you go to the official image, so you will get Bitnami. Bitnami is like official images are there, like Zookeeper image, Kafka image. This is some like my user ID is there, and I have created some image of Kafka and I have put it in the Docker Hub repository. So Docker Hub repository has these images. So I'm accessing, but this is a public image. That is the reason I'm able to access this image from somebody's image. I'm able to access, right? Because this image is a public image. Okay. So everybody, like, so they will get the count, right? How many images are accessed, right? How many people have pull the images, Okay. So this Docker compose YML file, Docker file, only one image it will do at a time, right? But here it is a container, different containers. So image and container, what is the difference? Image is a logical thing, right? Which is not, it is a static part. It is a static. Nothing is a running one. Was same image, if you pull from the Docker Hub repository and you use the Docker run command to run, that image will become a container. So you can think of image will become a container when it is run. Okay. When image is run, then it will become container. Okay. Okay. If you are not running image, just you have pulled the image, so it's image only. But same image, if you run it by using the Docker run command, then it will become container. Okay. So you can see through the Docker ps command. Okay. So this is all container. So you just have this Docker compose YML file, and this one will start all the containers separately. So same way like Airflow is here, Kafka is here, okay, and Postgres is here, and other one Spark also you want, so you can add Spark also. If you want Hadoop services also, you can add Hadoop also. So entire one cluster you can create, right? One single node cluster with all the containers. Okay.
Can you share the link in the chat, please? Yes.
Okay, let me solve this. So containers one is easy, it will be done quickly. PC container one. Okay, so here is this Docker compose file is there. So there are command Docker. So Docker you need and Docker compose also you need, because for running a Docker compose, it's on top of the Docker. There is a Docker compose also you need to. It's just one single command you have to run, and then Docker compose will configure. So there Docker compose up command is there. Okay. So first we change some port there. Okay. First we check what is the error is. Okay. So Docker up command is wherever your Docker compose file is there, you don't need to give the file name. Just do Docker compose up. So it will start. It will be pulling the. So in which containers is getting error? See, bind error is coming. So bind error is like already some port in use, right? So it is giving, because my nifi is not stopped, right? So that is giving. Okay, not nifi, this 8080 for some other. So this 8080 where I'm using 8080, I will change the port. So that is the better way. Okay. So I will change the port for that. So I will open this Docker compose file. Okay. So here this port I will change. $8090 I'm making it.
Change.
No, 8090 actually was not saved. So 8090 and Zookeeper I stopped it. So now it should work. Kafka I stopped it. It should work. Okay. Docker compose up. Which port? Kafka container, starting Kafka. Zookeeper. Nice. Okay.
So if we want to create a Docker compose YAML file to provision a lot of resources, are we going to write those configuration files ourselves, or we can just get the template online to use?
Yeah, this is online only, right? So this, which one you are saying? Like this Docker compose one? This containers configuration?
Mhm.
Which one you are saying? Like this containers one?
Yes.
Yeah, so this one we can get online, right? Like Spark I want, but one particular compose file, YML, you will not get everything, because depending on the use case, right, what they are going to use. If they are doing the pipeline of the Spark, Kafka, Cassandra, Airflow all together, there you will get all the containers. Otherwise, you can bring the Spark container and copy here in this one. Okay, because it's a separate service, right? All are the separate service. So separate service is there, right? So if you want to use the okay, Spark also, the Spark you need. If you want to use Cassandra, so Cassandra you can use. And you can say, okay, your data is coming from the, you are saying your data is coming from the some REST service, and then you are writing to the Kafka topic, and from there you are reading from the Spark consumer, and from there you are writing to the Cassandra. And this entire pipeline you schedule through the Airflow. So that is the one use case, like complete pipeline. This is the same pipeline, which example is, it's the same using like a Spark, and I think Spark is not there, but okay, now every container is up, right? There's no error. Now we can check Docker ps command. Ps. So it will be showing me what are the containers are there. You can see Zookeeper container, Kafka container, and Airflow container, and Postgres. Total 4 containers are there. So they said the 4 containers will be up. Okay. So here we'll only have 4 containers, because other example with the 5 containers. Okay. So 4 containers will be up right now. Okay. So if you see this, so you can see all the containers you are getting. Okay. And now we open the port. Okay. We open the port for 9093 for Kafka. Airflow we given 8090. Okay. Now we open localhost.
What?
Okay, we have to go to the container. How to go to the container? So this is a Docker execute IT. IT is for interactive mode. Okay. So for any container you want to go inside the container, so you should know the container name. Okay, you should know the container name. So we can get
You wrote TLI.
or container ID. We can give the container ID, like, because if we are not able to find the so container ID we can give. So this one is the IT, and container ID is here. This is the container ID. This container ID. Even the name is this one. So I paste and then go to the
What
container.
is
Now
IT?
I'm inside the container. So here you see, oh, ls will not work. Ls. So here you see DAX folder is coming, right? So DAX folder is coming, cd DAX. Here is oh, ls. So here is some already this guy has given the DAX, already predefined DAX, right? So he has given the DAX, Spark consumer DAX and the data stream DAX. So these are the DAX already provided. Okay. So if I want to copy my DAX, I will copy here. So I told you, right, we have to copy from the directory that is like some directory is a map to the, so wherever my this installation folder here.
Sea of horrors.
Here. Here flow that. Here in the root, this directory, here the dot. Okay. Here is the, I think here inside this. this one. This is the outer directory tags. So here, if I keep something, it will go to my, if I go inside cd tag, ln, see, same thing is coming here and there. This is my home directory, like my home directory of my project. I created, this is a dot slash tag. So in the compose by ML, I given this DAX to map to the my container directory. My container one is user local airflow DAX. This is my container. So if you see the same content, whatever is here, same content is there. If I keep it anything here in this DAX folder, if I create a new DAX here, vi, I say I want my own DAX file. This one shall. So I will be this. So I'm just copying different operators. I'm just defining here. So this will be shell script is in mine. So I should have this folder with these two shell scripts. So I'm just creating this. This is a main tag file which will be executed. Okay. Okay. Now I check here. ls. Can you check here? Shell tag file is coming here. Same file in the container is coming, right? So here I just created a file and I'm able to see in my container. Okay. In my container, I'm able to see my shell tag file. Okay. In the container. Okay. So echo Java home. If we are in container, if it shows the Java version, otherwise we have to export this one. So we are in container. This is the container. Okay, so container is having Java. Okay, USR there. It is equal to Java version, then where is when the airflow server. Oh, we have not started the server, right? Okay, so here I have to start the two commands. Okay, because I have to tell about this is the port where my server is running. So I kept it port 8090, right? 8090. 8090 my port. So I will start two files, two commands. I will start one is a web server, one is a scheduler. Okay. So I will start inside my container. I will do Python. Oh, shell tag file. So failed to import user local airflow shell tag failed to import. First I remove. So I start again now. Is saying not only for this, every tag is failed to import. info. No such table connection. Okay, I think database is not that. It's a local database for this. No such table job. Okay, I think this SQL Alchemy database is not initialized. So that is the reason of saying no such table job is there. So post this. We run this Docker build also because that is doing. This guy has not given the Docker file. This guy is not giving- Oh, he has given. So this Docker file we needed this Docker file and content of Docker file. Okay. This one we have to run it so that it will initialize the entire process of the Docker. Okay, like whatever the database is not getting. So we have to run this Docker file. Okay, so this Docker file we have to run by using the Docker build command. So if you were doing a manual installation, so we don't need this Docker field. So whatever command in the Docker file, so we are running manually in the terminal, and then we will install. Okay. This is server. Let me install this one. So tomorrow I will show manual way. Okay. think here is I'll figure it out. What is the container problem? Okay. So I will do it this example. Okay. So this is the simplest one. Okay. Like one shell script is there, and we are calling two shell scripts. One is a task T1 and one is a task T2. So bash operator is like basically calling one shell script. So this shell script will be called first shell one, and shell one is creating some file, some hello world file it is creating in the airflow DAG folder. And another shell script is copying this file to another output directory. So this is like multiple command we can use, okay, in our DAG, and this have the dependency by using the double greater than sign. So like once T1 is finished, then T2 will start, and T2 is finished, then T3 will start. So we can define the task dependency. So every task is like an operator. We are showing the operator. So if we are defining the bash operator, so we are giving a bash command. If I'm doing a hive operator, so hive shell script I'm giving. If I'm defining the spark operator, so I will be giving a spark submit command. So I will define a different operators and give the dependency. So depending on the one task is completed, then the another task will be triggered. So in the airflow DAG, there is a default parameter. If you are not setting any parameter, so you will take this default. Like what is the start of the DAG, what is the email, like in the failure. So if you make it true, so your email will go to the one specific email ID. Okay. And retry mechanism you want to give it. These are the default parameters. But you can create your own DAG variable, and this DAG variable will be override the default parameter. So if you are not setting your own value, it will be taken from the default one. Otherwise, you can change here your own configuration. You can change it. Okay. So this DAG variable basically further you are passing to your operator. So bash operator is dependent on the DAG variable, and this DAG is depend on the default argument. Okay. So whatever operator you want to use, suppose you want to use Python operator, so you will define a Python operator task, and Python operator will call the function. So that way we will define the Python operator, or any other operator, hive operator, scoop operator, we can define. Okay, I'll show tomorrow this like DAG to run. Docker one will see, and this one also. Okay, manual installation. Okay, thanks everyone for attending session. Thank you.
Thank you.